So thank you, Peter, for this introduction. And also would like to thank the invitation and the opportunity to have the presentation of Annex 75. So I will try to give a very short overview of the work that is being carried out in this annex, cost-effective building renovation at district level, combining energy efficiency and renewables. And as you can see, we have 13 countries participating in this project. They are mainly from Europe. And we started back in January 2018, and we expect to finish it by June 22. So we have 1 more year to finish the work and to prepare all the reports we have promised in this annex. So in this project, the major goal is to reach cost-effective energy and carbon emission optimization in building renovation at an urban district scale, combining both energy efficiency measures and renewable energy measures. So the key issue in this project is to find the balance point between energy efficiency measures and measures that promote the use of renewable energy. I must say that we have done this in a previous project in Annex 56, but we did it at the building level. And now in Annex 75, we want to do it at the level of groups of buildings or at urban districts. So at district level, there are specific opportunities as well as specific challenges that when compared to the building level. So finding the balance between the renewable energy supplies and energy efficiency measures for the renovation of the existing stock is much more complex at district level than for individual buildings, but may also bring larger benefits. There are several options available that need to be explored. And just to point out some few examples, there is an opportunity to benefit from district-based renewable energy approaches. The availability of heat storage facilities are wider at district level, as in a single building intervention, the options are limited to the building floor space. We can also benefit from significant economies of scale for energy efficiency measures due to aggregated demands and synergies in construction procurement, process, and planning. And the provision of district heating systems to groups of buildings may benefit from synergies when combined with energy efficiency measures applied to the building envelopes. But there are also some challenges. At level of individual buildings, these synergies between energy efficiency measures and the installation of renewable energy systems can be easily achieved. But at district level, these synergies are not necessarily available, as they depend on the existing heating systems and on the synchronization of the building renovation cycles. So in this context, it is important to explore the potential of cost-effective renovation interventions at district level to accelerate the necessary transition towards low emissions and low energy districts, which is essential to reach the full decarbonization of the economy by 2050, which is here in Europe a major goal. So the Annex 75 project aims to make a comprehensive analysis that covers not only the energy, economic, and environmental issues, but also wants to identify opportunities and barriers in the relations between the different stakeholders and in policies and incentives for boosting energy renovations. So we started with a lot of questions to which we want to find some answers. Just to mention a few, and starting with the basic question in our context is, what are the most cost-effective combinations of renewable energy measures and energy efficiency measures? This is the basic one, but we have many others, like, for instance, which factors determine the cost-effectiveness of the balance between energy efficiency and renewable energy measures? What is the most cost-effective approach between a centralized or a decentralized approach? Which technologies are seen as most relevant? How do energy efficiency measures relate to technology choices? And to what extent are the energy efficiency measures beyond energy renovations cost-effective? And is the cost effectiveness of energy efficiency measures the same for different renewable energy options? And which approaches allow achieving districts fully supplied with renewable energy at the lowest cost? So these are some of the questions that we want to find the answers. We have not yet the answers to all of them. We are still working on this. And to find the answers to these questions, we have defined a few objectives in this project that are summarized here. You can see, so the first objective was to give an overview of various technology options, taking into account existing and emerging efficient technologies with potential to be successfully applied. It was also an objective to define a flexible methodology supported in efficient tools to identify these cost-effective strategies for renovating urban districts. We also want to identify and document good practice examples, and our major goal is to prepare guidelines for policymakers and energy-related companies, and also guidelines for building owners and investors. Some of these objectives have already been achieved, others are still in progress, but we have already produced a report that is available in our website, in Annex 75 website, that presents an overview of the available technologies for energy renovation and renewable energy supply at district level, that shows the technical and economic characteristics of the technology options, taking into account economies of scale. It also shows interdependencies, obstacles, and success factors for combining the technology options, and also shows available potentials and expected future developments. We have also finished the report that describes the methodology that we developed. And in this document, it is defined the boundary conditions for the assessments, the recommended approach for the assessments, the main research questions to be investigates and defines the outputs to be generated in the analysis. And to support the application of the methodology, we have also developed an online calculation tool for district sizing and cost effectiveness of the renovation strategies. In this project, we are also dealing with case studies, and we have two different types of case studies. We have one that we call them success stories that are already finished district-based renovation projects, where economic, technical, and social factors that enable or hinder successful renovations were identified and analyzed. And we have the case studies that are open renovation projects that are being used to apply and to test the methodology developed in Annex 75. And hopefully, there is still the possibility to provide guidance in choosing the most appropriate renovation strategies, especially in finding synergies and trade-offs for combining energy efficiency measures and renewable energy measures. So the analysis of these case studies is still in progress, and we do not have yet many conclusions to show, but we have already collected and analyzed 16 success stories in different countries that are also available in our website in an interactive map where you can find detailed information on each of these 16 success stories that we have collected. And from the analysis of these success stories, and also from the application of the methodology to some case studies, we have already come to some conclusions that we have published in two scientific journals, one mainly dedicated to the methodology and its application to a case study, and the other mainly dedicated to the analysis of the success stories. And the major conclusion in both is indeed that the renovation at district scale is a cost-effective key strategy to boost the reduction of CO2 emissions by optimizing the implementation of renewable energy sources and taking advantage of economies of scale and higher levels of efficiency regarding the use of resources and waste minimization. And especially from the analysis of the success stories, we have already identified some drivers, barriers, and lessons learned that I can show just a few of them.
Manuela?
So, yes.
Manuela?
Yes.
Can you speed up a bit, because we're a bit running out of time?
I'm finishing. Yes, I'm just to show you this the major conclusions. So relating to the drivers, they are not restricted to energy savings and emission reductions. They also include improving the overall quality of the building, including indoor climate, improving the image and the economic value of the district, and the existence of financial models that can alleviate split incentive problems between investors and resident organizations. And as barriers were pointed out, the need to comply with the increasingly demanding energy regulations, restrictions in the renovation scope to avoid a clear increase in the rent, and the resettling of tenants during the renovation, which is often not possible. And some lessons learned that I can point out a few. So most important is available funding is a decisive factor in carrying out a district scale renovation. But also good communication among the different stakeholders is important, especially with residents. It is also needed strong leadership to coordinate activities due to the great number of stakeholders involved in these processes. It is also important to engage the citizens. And important also is the existence of pilot projects to demonstrate the possibilities, and also the availability of not only technical solutions, but also business and financing models, as well as local policy instruments to assist local uptake and co-creation in municipalities, cities, and regions. And finally, to prepare the guidelines for policymakers and building owners. That is our most emblematic outputs. We have been promoting several workshops when it was possible to have them, but also webinars and interviews, online interviews with different stakeholders, especially dedicated to policy instruments, stakeholders dialogue, and business models. But this activity will be presented by my colleague, Erwin Melknik, that is the leader of this task in this annex. So, Erwin, the floor is yours now. Thank you.